Hello everyone, in this video we are going to understand about the Lagrange's interpolation method. So we will take a working example to understand this method, and after that we will see that how we can implement this method using a C program. So let's start. So in the previous video, that is in the Newton forward interpolation method video, I have discussed that why do we use the interpolation, or what is the motivation behind the interpolation methods. Okay, so you can check that video. The link of that video is in the description below, or you can find the I button also. Okay, so just to recap, for example, we are given this table. Okay, now we have to find that at a particular point what is the value of y. For example, we are given this table. Okay, and we are asked that at particular value of x, for example, let's say at 9.8, what is the value of the y. Okay, and we are not given any function. So for example, if we are given a function, let's say fx, and let's say this is the function, and it is said that at f of 5, if we put here, then we get, let's say, 12 value, although we will not get 12 value here, but let's say this is the function which is defining this table or this pattern, that at x equal to 5 we will get 12 value, at x equal to 6 we will get 13 value using this function. Then if we are asked that at x equal to 9.8 what will be the value of y, then you can simply put 9.8 in this formula or in this function, and you can simply find the corresponding value of the y. Okay, but if we are not given any such type of function, and we are simply given this table having the values of x and the corresponding value of y, and we are asked that please tell me at this given x value what is the value of y. Okay, so at these situations we use the interpolation formulas, which will help us to find the value of y corresponding to a given value of the x. Okay, and this x value can be any one, like it can be like in between 6 and 9, in between 5 and 6. So for equal intervals there are various methods which can help us to find the corresponding y for a respective value of x, and I have discussed those formulas or the name of those formulas in the previous video. Okay, in the Newton forward interpolation video, so you can check those in that video. So in this video we are going to see that if the intervals are not equal, then what are the available formulas to find the value of y. Okay, so what is equal and unequal interval? So for example, here you can see that the gap between 5 and 6, it is 1. Okay, and the difference between 6 and 9, it is 3. Difference between 9 and 11, it is 2. So that means these values of x, they are not equally spaced. Okay, the difference between these x value is not equal. Here it is 1, here difference is 3, here difference is 2. So this is called unequal intervals. Okay, and what is the example of the equal interval? For example, the x values are something like 5, 7, 9, 11. So the gap between all the x values is 2. So this is the example of the equal interval. So we have to see that if the interval or the gap between the corresponding x values is not equal, then what are the various formulas to find the value of y for a given x value? So there are many two methods available for this. First one is Lagrange's interpolation method. Second one is Newton's divided difference method. Okay, so in this video we are going to understand about the first method, that is Lagrange's interpolation method. So let's take a working example to understand this Lagrange's interpolation method. So here you can see we have an example. So in this question we are asked that if we are given this table where we have the various values of x like 5, 6, 9, 11, and the other values of y are 12, 13, 14 and 16. Okay, and we are asked that at x equal to 10 what will be the value of y. Okay, so x equal to 10 will be lying here. Okay, so what is the value of y for this x equal to 10? So we can see here that the difference between these x values is not equal. Okay, so difference between 6 and 9, it will be 3, and difference between 9 and 11 is 2. So these gaps are not equal. So we can use the Lagrange's interpolation method here. Okay, so let's see how. So this method is actually very simple. There is a simple formula to find the value of the y at corresponding value of x. We will just apply that formula and we can easily find our answer. So let's see what is the formula. So here is our formula of the Lagrange's interpolation method. So here this f of x is actually your y. Okay, and we know in our question we are asked that x value is 10. So this is actually the value at 10. Okay, so this we have to find out. Now here we have various terms. Okay, so you can see this is, let's say, one term. Okay, this total is, let's say, second term, and so on, and they all are added. So this was our question or the table that we are given. Okay, and at equal to 10 we have to find the value of y. So here what is the formula saying? See, it is very simple actually. So in the formula you can see how many terms are there. So you can see this total is 1. Okay, this total is the second. Okay, and this total is the third thing, and this total is the fourth thing. Okay, so there are 4 times we are adding some of the terms, right? So this formula will be like, you can say, go on till n terms. Okay, for example, here 4 terms are there, so 4 times we are adding. If only 3 terms were to be there, for example 5, 6, 9 only, okay, and 12, 13, 14, then only 3 terms will be there. Okay, so now let's see how we can find these various these values. Okay, now let's say you are at this position, okay, at x equal to 5. So what you will do, you will simply write x minus something, x minus something, and x minus something, right? Okay, again divided by, you have to write something. Now in the denominator what you will write? Okay, so here you can see x1, x2, and x3. So what you have to do, if you are currently at this position, so you have to treat this 5 as x0 and all the remaining x as x1, x2, and x3, right? That means this is x minus, okay, x minus, here it is like x1, x2, x3. So what does it mean? It means if you are at this position, just ignore this. Just ignore this and take the remaining values 6, 9, and 11. Okay, and these are termed as x1, x2, x3. So x1, x2, and x3. Okay, now divided by, again you have to use this x1, x2, x3. You can see here x1, x2, and x3. Okay, but in place of this x, now you will write this 5. Okay, or you can say this x0. So you will write x0 minus x1, x0 minus x2, x0 minus x3. Okay, only this x0 will be used in the denominator. Multiply with this value, that is the function value at 5. Function value at 5. Now what is this 5? This is termed as x0. So this is the same x0. Okay, I directly use 5. Now you come to this 6. Okay, so when you are coming at 6, so this will be treated as x0, and remaining values, okay, remaining values will be treated as the same that we have understood. Now you come to your 6. Okay, so what you will do, again you will write x minus something, okay, x minus something, and x minus something, right? Now what will be the something part? So you are at this position, so now you will ignore this 6 and you will use the remaining values 5, 9, and 11. So 5 is x0, 9 is x2, and 11 is x3. So you can see your x0, x2, and x3 are used, right? So same thing you will use here. Now divided by, here you can see that again x0, x2, and x3 are same as numerator, but you are currently at 6, so now you will use this 6. Okay, so here you can see x1, x1, and x1 is used. Okay, now multiply f of x1, that is at this current 6, what is the value? That is 13. So same way you can write the next term, third and fourth term. Okay, so at this position in the numerator you will ignore this 9 and you will use x0, x1, and x3. Okay, x0, x1, and x3, and in the denominator you will use this x2. Okay, x2, 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 and remaining these things will be same. Okay, and then at this f of 9 or f of x2, you are using the value and you are multiplying. Same way you can use with the fourth term. Okay, so I hope you have understood this formula, and there is no need to learn this formula. Okay, by simply seeing the table you can just write the various terms. So let's put all the values of these x and y's in our formula and see how we can find the answer. So here you can see we have put the various values in our formula. So here you can see this x is the same thing that we have to find. This x is actually 10. Okay, but we are not putting it right now. Okay, but we have not put this x equal to 10 right now. You can also put x equal to 10 here only. Okay, so here we have put the x minus. Now at this position when we were there, we were like not using this in the numerator. We were using 6, 9 and 11, right? So this is 6, 9 and 11. We have put the value, and in the denominator this was the same thing, 6, 9, 11. Okay, but here what we were using the same value that we were inspecting. We are currently present at 5, so we are now writing this 5. Okay, now multiply. What is this 12? This 12 is like f of 5. Okay, f of 5, same thing that we have used in our formula. We will come to here. So now we will ignore this in the numerator. Okay, and we will use 5, 9 and 11. So you can see 5, 9, 11. Okay, now in the denominator again 5, 9, 11 will be same, but now we will use this 6, 6, 6 and 6, right? Okay, now multiply. We will use this 13 value. Okay, 13 value. This is like 13 is f of 6. So this is f of 6, right? The same thing we will use with the third term, that is we will not use this 9 in the numerator. We will use 5, 6, 11. Use 5, 6, 11, and in the denominator 5, 6, 11 are same, but we can now use this 9 as the x value. Okay, multiply the corresponding value at this f of 9, and so on with the fourth term. So now what we can do, we can also put x equal to 10 here also. Okay, so if we put like at every position we just put x equal to 10 and x equal to 10 and so on, so we will get all the numbers, right? All the numbers. Okay, or we can do like what, we can simply solve this in the form of x, and we can then at last put the value of the x. So here you can see now at last we are putting the x equal to 10, and everything is like in the numbers form, and we can simply find the answer. So answer is 14.666. So that means at 10 the value of y will be your 14.666. Okay, so I think it is very easy formula, and you can simply put the value very easily. Okay, so the simple thing is you just remember the pattern that we are following in using our formula in this Lagrange's interpolation method, and you put the value correctly and you can simply find the answer. Okay, so now let's move to the implementation part. That is, we will first see the algorithm for Lagrange's interpolation method, and then we will see a C program to implement this question. So this is the algorithm for the Lagrange's method. So what we have to do, first we have to enter how many terms are there. Okay, that means we have x and y, and there are some values of the x. Let's say it can be like 1, 3 or then 10. Okay, and let's say for the y we have some value, let's say 3 and 14, 17. Okay, so we have to enter the values of the x and values of the y. But before that we are asking the user, okay, how many terms there can be in your program. So in this question we have 3 terms. Okay, 1, 2, 3, the same corresponding 3 values of the y. Okay, so this n will be storing that thing. So here n equal to 3 you can say. Now we have to save, or we have to ask the user to enter the values of the x and enter the values of the y. Okay, that means we are actually constructing the input table, right? So how we can store these x values and y values? So we can simply take a 1D array for the storing the value of x and storing the value of y. Okay, so as there are n terms, so the size of the 1D array will be n. So X array is of size n, Y array is of size n, and we can ask the values of the X and Y from the user. After we have got the values of the X and Y from the user, what we have to do? We have to ask the user, okay, tell me what is the value of the X at which you want to find the value of the Y. So for example, in our given question, what we can do here, let's say we want to find the value of, let's say at X equal to 7. Okay. So at X equal to 7, we want to find the value of Y, right? Now apply the formula and finally we can find the result. So let's see the pseudocode for this method now. So here you can see we have entered the values of the X inside this X array, and we have entered the values of the Y inside the Y array. So we can simply use a loop to enter these values. Okay. So let's say we have the X array. This is X0, X1 and X2. Okay. Let's say we have 3 terms only. So values we can put inside this array. Okay. Some values. Okay. The same way we can put the values inside Y using this loop. So this loop is running n times. This loop is running n times, and we are scanning the value inside X array and Y array. Okay. So after we have got the values of the X and Y, what is the next thing? We have to ask the user the value at which we want to find the value of Y. Okay. So this is simple. Okay. Now after that, what we have to do? The main thing is we have to apply the formula. So in Lagrange's interpolation method, the implementation part is like mostly concerned with like how we can implement this formula. So let's see. So here you can see we have this table, okay, as the input, and we have this formula, right? So we have to implement this formula into our programming. So let's see how we can do that. So now before this, we should know how this code is written. So what I have assumed that this is actually a series. You can say this is a series, and this series consists of many terms. Okay. So I will treat this as one term, again this as the next term, and so on. So there are total 4 terms in this series. And what we are actually doing, so for example, I write this thing, okay, and for example here it is like 1 and it is 3 and 5 and 9. So let's say we are given this series and we are asked that please find the value after adding all these terms. So what you will do? So in programming, you will just simply run a loop 4 times because there are 4 terms, and okay, from I equal to 0 to n, and after that you will just use sum equal to sum plus or any other variable plus. You will say, okay, let's say this is stored in an array, this is stored in an array, this is stored in an array. This is A0, this is A1, this is A2, A3. A is I am treating a array. Okay. So you will simply write A of I, right? So this A of I is actually a term, right? Which you are adding again and again with this sum. Okay. So for the first time, it will be like initially we will take sum equal to 0. So it will be like 0 plus, for the first time A of 0 will be 1. That means 1. So inside sum, what is the answer? 1. For the next time, for I equal to 1, this will be A of 1. That means 3. Now 3 will be added with this previous sum. Okay. 3 is added with the previous sum. So 3 plus 1, 4. Okay. The same way, you can add 5 with the previous sum. Previous sum is 1 plus 3. Okay. So in this way, you are storing the, you can say the previous sum into a variable sum. And in the next iteration, you are adding this previous sum with the current value or the current number present inside your array. The same thing we have to do here. Okay. The difference is the terms are not simple. Okay. These terms are not simple. We have to first calculate these terms, and then we have to simply write this sum equal to sum plus your term. Here you can see we have taken 2 loops. Okay. Again, I have taken another loop. Okay. And after this loop is over, which loop? This inner loop is over, I am saying sum equal to sum plus your term. And with term, I have just used some another value, that is the value of the y. We will see it later. Okay. So this is the same thing, sum equal to sum plus something, sum equal to sum plus something. And again in the next iteration, again for I equal to 0, let's say we have found the sum. Then for I equal to 1, again we will do something in this inner loop, and again we will say, okay, sum plus term. This term is coming from where? So this term is coming from this inner loop. Okay, so whatever term is prepared inside this inner loop, it is getting used here. Sum equal to sum plus this. Okay, so at I equal to 1, let's say I got some answer. So when we are at I equal to 1, what does it mean? So in I equal to 0, we will find this total answer, which will be stored inside sum. In the I equal to 1th iteration, what we will do? We will first find this answer, and then we will just say sum equal to sum plus your this current term. Okay, and previous sum was this. Now when I equal to 1, this iteration is finished. Then inside sum we have this and this answer. Okay, the sum of both these terms. When we will come to I equal to 2, that is the second iteration. Then we will say first find this term, okay, and then add with previous answer. Add this term with previous answer, that is previous answer plus your current term. So in this way, we are again and again finding the sum. And when this outer loop is over, we are coming out and we are printing this sum, because this sum is actual answer that we want. So now let's see all the intricacies of this thing, that is how we are finding the term. Okay, so now before proceeding, here is one assumption what you can think of. And this is not assumption, this is like basic mathematics that we are actually using. So for example, if you are given something like, let's say 2 multiply 3 multiply 5 upon, let's say 3 multiply 7 multiply 8. So can I write this thing as like 2 upon 3 multiply 3 upon 7 multiply 5 upon 8? That means I have grouped these 2 and 3, then 3 and 7, and 5 and 8. Okay, so if you find the answer of this and if you find the answer of this, both will be same. Okay, according to mathematics, these both are equivalent. So same property we will be using here. So this is the thing that we are seeing here. We will actually use this thing in this way, that is we will write this thing in this way in our programming. Okay, so let's see how. So here you can see for I equal to 0, that is for the 0th iteration we will run, and this I loop is running till n times. That is for I equal to 0 it will run, and in this question we have n value as 4. So that means I equal to 0, I equal to 1, I equal to 2, and I equal to 3. Total 4 times this loop will run. So currently I is 0. Okay, now let's forget this thing for the time being. Okay, so we have again used a loop which will actually calculate our term. Okay, now specifically talking, this will be your term which we will be getting after this loop, inner loop will be over. This term, that means this total answer, will then be multiplied with this y of I. What is this y of I? So this is like at I equal to 0 we are here. So this is actually y of 0. Okay, at I equal to 0 this is y0, that means this 12 value. Okay, so this 12 is multiplied with this term. Okay, so in this way this is your term multiplied with y of 0. Okay, this way we will be finding this sum. So let's see how this term is calculated. So the thing is, what I have told you, that inside your formula, when you are at, let's say I equal to 0, then you are not using this in your numerator. This 5 is not getting used in numerator. Remaining values 6, 9 and 11 were getting used. When you will come at I equal to 1, then you will not use this 6. You will use the previous value 9 and 11 in the numerator. Here you can see 5, 9 and 11 will be used in the numerator. So this is the main thing, that at I equal to 0, you are skipping this 0th value of the x. At I equal to 1, you are skipping this value, this xi value or x1 value. At x equal to 2, you are skipping the x2 value. But how we can skip? So for that skipping thing, we have used this condition. What does this condition mean? So let's see. So here you can see we are running this j loop, j equal to 0 to j less than n. Okay, so n is your 4. Okay, whenever we are coming to this j loop, n will remain as 4. So that means this j loop will run for like j equal to 0, 1, 2 and 3. Okay, 4 times every time. But here you can see when we are calculating the term, how many things are there. This is one thing, then this is the another thing, and this is the another thing. Again in this term we have like 1, 2 thing and 3 thing, or 3 groups. So in each of the term we have the 3 groups, but this loop is running 4 times. So what we are doing, we are saying please skip when this condition is not true. Okay, so what does it mean? So this says, let's say at I equal to 0 we came at j equal to 0. Okay, so I is 0, j is 0. So for the first time what we have to do, we check if both I and j are not equal. You will say no, they are equal, I and 0 are equal. So we will not run this statement and we will skip. We are currently at j equal to 1. Okay, now we came, I is 0, j is 1. Both are not equal, so true. So we came inside. And here we are saying, okay, this is your thing, multiply with the something. So let's see what is this thing actually. So this is like, this x is the same thing that we have to find. Okay, this we have asked from the user. So this x is the same thing. Okay, this x minus. So here you can see this 6, 9 and 11. This is 6, 9 and 11. What is the position of this 6, 9 and 11 in your x array? So this is at 0 position, 1, 2 and 3. So this is your x1, x2 and x3, right? So we have to use this 6. So here you can see this 6 is at 1th position. That means currently j is at position number 1. Okay, and same thing we have to use as the 6 value. So you are saying x minus x of j, that is x of 1. So x of 1. So x of 1 is actually this 6, right? Now divided by, we have to write this 5 minus 6. What is this 5 and what is this 6? So 6 is the same thing. This is the thing, right? That is xj, that is x1. So same, you can see xj and xj. Now minus, what is this? So you can see when we are at this I equal to 0 position, we have to use this 5. So this is like dictated by I. We will use xi. So currently xi mean x0. So x0 is 5. So we have found this thing, right? Now here you can see, let's say this is some value, let's say 5. So 5, when next time we will find this value, what we will do, we will, let's say this is 7. Okay, this is 7. So we will be multiplying this 7 with this 5, and when we will be finding this answer, x minus 11 upon 5 minus 11, let's say that is like some value, let's say 100. Okay, let's say 100. So then 100 will be multiplied with the previous answer, right? So again what we are doing, we are multiplying the current thing with the previous thing, and previous thing we have to store some here. So for that we have used a variable term. So here you can see we are multiplying this x minus 6 upon 5 minus 6 answer with the term. Okay, now you tell me, if I multiply something with let's say anything. Okay, let's say if I'm multiplying this thing with this thing and I want only this answer. Okay, after multiplying we want the same answer, then what should be the value inside this term variable, so that I get the same this answer? So you will say if term is equal to 1, then only we will get the product of this term and this term equal to this one. Okay, this term should not be 0. So that's why I have used the value, initial value of this term as 1. Okay, so this total thing multiply this term will be saved inside this term. Okay, so term is consisting of this answer. Now next, again j will be your 2. Okay, j will be your 2. Now j equal to 2 means you are at this position. You can simply say, okay, this way. Now again I and j are not equal. Okay, I is 0 and j is 2. So you will come again inside this condition. And now you have to find this answer. So this is like x minus, again x minus. Okay, so this is 9. That means you want this answer. Okay, so this is x2 and your j is holding 2. So you can simply say x of j. So here you say x of j. Okay, so now divided by, again here you will be using x of j, x of j. Okay, but here what you want, here you want the same 5, here also you want the same 5. That means whenever you are at the this I equal to 0 loop, you want the same thing here. So this thing is not dictated by j, this is dictated by the I only. So x of I means x of 0, and x of 0 is same, okay, for any value of j. So this will be your x of 0, that is 5. So this term is calculated, and this answer will be multiplied with this term. Okay, multiply with this term, and again save inside term. The same way for j equal to 3, again you will calculate this answer and you will multiply with the previous two answers, okay, which is saved inside this term. And after this j loop is over, you have the product of all these three terms, and this answer is saved inside this term. So after this for loop, what you are doing, you are simply saying that I have found this answer which is stored inside this term. I will multiply with this thing. Okay. So what is this 12? So this 12 is the corresponding value to this 5. Okay. So we are at 0th value, that is at I equal to 0. So we want the y0 value. Okay. So we are multiplying with the yi because I is 0 here. Okay. So term multiply by I. So this total will now be saved. Okay, this. And what we are doing, when we have found this term answer, we are adding with the sum variable. Okay, and sum initially should be 0 or 1. It should be 0 because we are adding, we are not multiplying. Okay, when we are multiplying something, okay, then the initial value should be 1. Okay, in the case of addition, we want the initial value as 0. This is important. Okay, and we are adding with this sum. Again, for I equal to 1, we will be computing this answer. Okay, so for I equal to 1, again we have to refresh this term. Why we have to refresh this term with the 1 value? Because here what we will do, when we will find this answer, this should be multiplied with what value, so that we get only this answer. So for that, your term should be 1. Okay, if term has the previous answer, that means this answer, then this thing will be multiplied with this thing, which we do not want. Okay, so this line is important. Okay. So again you can see, again j loop is running from 0 to 3. Okay, and we are skipping when I is not equal to j. So I is 1, so we have to skip at this position, right? So for j equal to 0, we will say this condition is true and we will come inside. And here you can see, when we are at this position, we have to skip this 6. Okay, but we have to take this 5, 9 and 11. So when we are at this position, we are using this 5, right? So at I equal to 0 and j equal to 0, sorry, I equal to 1, we are coming here. Okay, and what is this answer? So this will be like x minus x of j. J is 0. Okay, so j is 0 means this value. Okay, so this will be your 5, that means x0 divided by, this is again xj. Okay, and this is xi. So xi is dictated by the current I, that is this 6. You can see this is 6. Okay, so again this is multiplied with the term, and so on. This thing will be like repeated again and again, again and again. Okay, so that we will find this answer. Okay, and after that, again we are coming here and we are saying this term should be multiplied with the current ith value of the y. Current ith value of the y is this. Okay, at I equal to 1, we have this answer, right? So this thing, again, this total answer will be saved with what? This answer will be added with this previous sum value. Okay, and this answer of this and this will again now be saved inside this sum variable finally. Okay, so in this way, our I equal to 1th loop is over, and now we will come to I equal to 2, and the same thing we will repeat again and again with I equal to 2, with I equal to 3, and so on. And at last, the total answer will be saved inside a sum variable. So when this loop will be over, we are coming here and we are saying, okay, print your sum, because this is the final answer. So this sum is saying that whatever given value of x was there. Let's say at x equal to 10, we want to find the value. Okay, so at x equal to 10, this sum is telling you the value, that is y value. So I hope you are clear with this pseudocode and how this code is running. So let's implement this into a C program. So this is your C program for the implementation of the Lagrange's interpolation method. So here we have started the main function. So here you can see we have asked the user first the number of terms. Okay, and then we have taken the two 1D arrays x and y, and we have the sum and term variable. Okay, so after that we have asked the user to enter the value of the x and enter the value inside the y array. Now we have asked the user at what value of x you want the value of y. Okay, and this is stored inside this x variable, right? Now we have to simply apply the formula. Okay, and this is the same formula that we have just described. Okay, so after this loop, we have just printed the value of the sum. That means value at x. Okay, this x that we have asked the user to find the value at. Okay, what is the value? That is sum. Okay, so let's run this program and see what is the answer. So here first we have to enter the number of terms. Okay, so it is like we were asking the 4 terms from the user, and let me enter the values of the x array. So this is the x array. Now enter the value of the y that we have just seen in our question. So this is the y array, and now at x equal to 10 we want the value of y, right? So here you can see value at x equal to 10 is 14.666, right? This is the same answer that we have just seen in our working example. So this was our code, and I think you have now understood that how we can implement our Lagrange's interpolation method in a C program. So if you have any comment, query, suggestion, please write down into the comment box, and do like and share this video. Please subscribe this channel and press the bell icon for further notification, because I make other videos on the other various topics like interview experiences, gate experiences, C programming, interview questions. So you can find all those links of those playlists in the description box also. See you in the next video. Till then, goodbye.